Hello, everybody. This is GenesisGir. It is May 18th, 2023. It's officially about to be 11 o'clock. We will begin at 11. Okay, it's officially 11 o'clock for me. Hello there, everyone. Today we're going to be going in depth about artificial intelligence, and more so not artificial intelligence, but about neural networks. And neural networks play a big part in the world of a lot of things that happen with technology today. We are going to be talking about the understanding, because if we want to truly understand object detection, ladies and gentlemen, we have to have an idea of what artificial intelligence is and how neural networks work. Artificial neural networks, right? And in a way, neural networks too. It's very complex. I don't think that if you want to just jump into object detection and you just want to understand to how object detection works, you kind of do have to go through the tribulations and the studies of artificial intelligence. Today is a beautiful day, everybody. It's another day that I get to learn. I want to thank everyone in my life, my mother, my fiance. I want to thank my family for the support that I've given. I want to thank anyone who is out there and finds these streams interesting. My heart goes out to you. But in a way, as human beings, we want to innovate and progress. You see this pattern in humanity. We always keep evolving. We make better things. We keep making them. We innovate. It doesn't stop. Did you know that human beings are one of the very few, is probably the only species on planet Earth that has this progression? We show no signs of stopping. It keeps getting more and more and more as the years go by, as the decades go by, as the centuries go by. We innovate, we change. And in this way, what does that have to do with artificial intelligence, and what does that have to do with programming? A lot. It has a lot to do. In the brain, we have these things called neurons. And these neurons are responsible for transmitting data, right? Assessing data. They're like little computers, and we have millions of them in our brain, right? We have millions of neurons in our brain. Now, in the sense of computer science, this is astonishing that we've actually even gotten to replicate this. The fact that we have replicated neurology is insane, right? It's almost, I want you guys to think of it as artificial means man-made, right? A plastic bottle is man-made. A chair is man-made. This television, your phone, they're artificial constructs. And what we are going to do in the future, which I'm very excited to announce on this documentation, and Genesis, if you're hearing this in the future, I hope you've learned a lot in the future. maybe you could write a comment down here of something that you've learned, you know, in the future. And if you're re-listening to this, because I know you watch your own live streams, I watch my own live streams, and I actually learn from watching my own mistakes, my own stuff, and I get better and better. So, what is a neuron? A neuron contains, its core purpose is to transmit electrical, well, it transmits data, right? Let's make sure we're right about that. So we're going to go to ChatGPT to ask the question, to beg the question. I want to make sure that I've studied it. That's what they've told me. A neuron contains information, and it transmits data through electrochemical transmission. Not electrical transmission like in a car or a light bulb, not that type of electricity. We have our own chemical-based electricity in our brains. Right? And this, let me check chat just in case we're, okay, just in case. We get these, we have millions of neurons in our brain. Now we want to replicate this. Object detection and programming works this way. I don't want to fall down the rabbit hole of, you know, I don't want to fall down the rabbit hole of it, because as we all know, it's easy to fall into rabbit holes in programming. So here we are. As you guys can see, I've done my studies. I've looked up what all this stuff is. I don't know 100%, but I've done my studies, right? On artificial neurons and neurons. And if you do want to study neurons, you know, if you want to understand object detection, if you want to understand how artificial intelligence works, it works with these convolutional layers. It's a very intricate system. And every artificial intelligence to this day has a neural network. They have neural networks and they have deep neural networks. Normal neural networks do not have hidden layers between the convolutional layers. This is a normal neural network. And deep neural networks, if you guys have ever heard of it, are neural networks with hidden layers, extra layers to do even extra processing, which makes them, in turn, more complex. Cool, right? You know, so if you guys were ever thinking, well, what's a deep neural network? Well, how could that benefit me? Deep neural networks have a way to, like, literally give you better results. And not just better results, they are actually capable of doing more complex tasks. You name it. If you guys don't know what Boston Robotics is, Boston Robotics is a place where they actually create robots. Obviously, for the name. And each one of these robots, look, as you can see, you see these squares. What's going on here? This is actual object detection happening in real time, right? So pay attention. The robot's getting up. That is a task. It's assessing. It's doing it on its own free will, and it's detecting objects like boxes, doing tasks like jumping. This is what neural networks help us do. As a human being, we have our own neural network, but it's natural. It's not man-made. It's in a sense of, it's organic. So ours is a little bit, will always be more complex than a robot, right? In a sense, like, maybe years from now we can get it down to the key. Like, that's just recreating the human brain at that point. But there's more areas in the brain that just has to deal with neural networks, right? There's more concepts. There's the frontal cortex, the cordyceps. I mean, you have a lot of parts of the brain, and I probably got that wrong. But anyone correct me, leave a comment in my videos. That's a good one. If you know anything about artificial intelligence, leave a comment. I do have to review every single comment because sometimes we get people from Twitch or just people in general. Not that much who like to, you know, leave nasty comments. So I gotta review everything that comes in, guys. Sorry, I gotta do it. I want to keep the environment safe for everyone. I want this to be a good learning environment. But if you have anything to share with me or anyone in stream, go ahead and leave a comment. Or even if you don't think that it's really important to teach, show it to me. Let's see what you have to offer. I want to see your curiosity. Remember, curiosity, once you open that curiosity door, once you open the door to curiosity, anything is possible. So, as you can see, they have these two types of models. They have the spot inspection solution. I guess that's not what it's called, but if we go here to learn more about this specific model, this is for industrial inspection, right? So this inspects industrial situations. I'm not going to click on it because I don't know copyright. Thermal sensing. It can sense thermal heat. Optional integrated thermal camera allows you to detect issue indicating hotspots in tanks, machinery, or electrical conductors. And how do you think it does this stuff? Through visual inspection, right? Maybe some other stuff too. I guess more so visual inspection. Is that insane? Because you know how there's some thermal night vision and you can see the body heat of, well, that's night vision. I know that there's a thermal vision, which allows you to see the heat rating off of an entity or an object. So maybe they're implementing this type. So I'm thinking the input going inside of this robot has to be a video or a feed of a thermal vision, and it's detecting, okay, this tank is hot, this one is cold, this one is so and so temperature. That's amazing, isn't it? It's amazing. Let me double check to make sure I'm not ignoring anyone. And we are live now. It is officially 11:11. My streaming times vary. As you guys can see, I'm streaming here at 11 a.m. in the morning. So I wake up like around 11, maybe sometimes the latest I will. It varies. It varies. Just make sure to go check out my Twitter. I'm going to post my Twitter to you guys. So how do you share a Twitter? Oh, okay. The link. URL, obviously. Duh. So, here's my Twitter. I should probably make a timer for that. So yeah, dude, it is really important that you learn neural networks. Even human neural networks. The deeper you have an understanding on how neural networks work, the deeper understanding that you will have on how object detection works, face recognition works, tracking, all that cool stuff. It all stems from the brain, my friend. Remember that. So, what are we going to do today? Today, we are going to do, I'm going to do more studying. I'm not going to talk through when I read. I want to make sure that I give you guys, or I give myself as well, the right explanation. So from now on, when I read a piece of documentation, I am going to read it silently and study. Okay, so that's exactly what I'm going to go do right now. I learned some newer things yesterday. There's these things called logic gates. Logic gates are the building blocks of a digital system. Okay, this has, I learned that yesterday. There's and. These are logic gates. What else did I learn yesterday? I learned about biases and biological neurons. Biological means natural. It is natural, right? Because if we look at, like, if you look at a biological ecosystem, you could really say that that's like the ocean. An ocean has a biological ecosystem going on. So does the forest has a biological ecosystem going on. Right? So when we talk about biological neurons, we're talking about natural neurons that occur inside of the human brain, not inside of a computer brain. Now, when we talk about artificial neurons, we're going to get to that. So, a neural network is a computational model inspired by the structure of... I'm going to read this to myself and I'm going to explain. So I'm going to do some studying. If anyone has any questions, make sure to ask. Go put on my playlist. Gonna go vibe now.
for promiscuous. My style is ridiculous. If you see us in the club, we're for promiscuous. My style is ridiculous.
Hello. Good evening. Welcome to my stream. How are you? Oh, you walked in your city? Wow. I envy you. Let me turn off the music. I envy you, man. Seriously, I'm kind of jealous. You're out there walking. That's good. I've been in my room all day, learning about some stuff, but I've learned some really cool stuff while you were gone. Yeah, some really cool stuff. So much. How was your day today? How was your day today, Luther? Do you like it? You want me to call you Luther or do you want me to call you Poflo? Which one do you like more? Yeah, but dude, oh my god, I got a lot of cool stuff to show you, man. Like, what the hell is this? I promise you guys I don't follow this stuff. This is just random Twitter stuff. Me, I'm good. Just learning, oh, look at this. I learned what coefficients are. I learned that recently. I learned what a coefficient is. I learned more about neural networks, and we'll get into that whenever we're ready. But yeah, I've learned a lot of stuff. But today I've been good. I got some food downstairs. I ate some food. My girlfriend's at work right now. I'm just chilling right now, you know, vibing and just cooking up code. How are you? Is the weather nice over there, or it's nice to talk about stuff other than code sometimes, and I have to force myself to talk about other stuff because sometimes, you know, I get so, my mind is so convoluted when it comes to programming. But it's healthy to talk about normal stuff like how your day was, chill vibe. That's good. Over here, the weather is nice, actually. It's nice and cool. Yeah, it's sunny. It's a nice day today. You know, one of these days, dude, I really want to go out for a walk, but my neighborhood is pretty dangerous. That's the problem. Where I live. You hate the sun? Yeah, when it's really hot, I can't stand the sun either. And it's weird because we're both Spanish, right? We're supposed to. What type of Spanish are you, Poflo? Are you caramel skinned or are you light skinned? Are you blanquito or are you like como café? Like, what are you? Me, I'm like light skin Spanish. But if I go inside of the sun for a long time, I turn like caramel. You know? 35 degrees. That's not that bad. Honestly. Yeah, I was just I'm yellow. Oh, you're the yellow type? Oh, okay. Wait. Are you Spanish? Wait a minute. I'm very confused. So you're like a yellowish, like tannish. Okay. I could see that. Yeah, I guess what I look like, I have brown eyes, dark Spanish hair. It's like what else? I wear glasses and I'm wearing a white, you know, one of those white office shirts with the red tie, and I'm wearing Converse right now. And I'm wearing like jeans. But but now that's how I dress at home right now. It's weird. It's very weird. I dress like Mike Wheeler. That's why he's my favorite character, Mike Wheeler. If we look up Mike Wheeler. Let me try to find a good image of how I dress. My hair is not kind of like his. Yeah, I dress like I dress like this, dude. With a sweater and everything. Not even gonna lie. This is the perfect representation. I have that same exact sweater. I have that same exact sweater, dude. This one and this tie. Yeah. But yeah, let's talk about normal stuff for now, then we'll jump into stuff like that. What do you have planned for today? Or like, what do you got planned for today, buddy? What are you gonna do? You just came back from school, right? Like an essay or like a love letter? Are you doing her homework or you're writing like a love letter for her? Cause that's kind of cute, dude. Like if you're doing that. Oh, you're waiting for your girl to get there? Oh, that's good. You know, go out, spend some time. It's good to get fresh air, you know? The little things matter too. Yeah, I'm waiting for my girlfriend too. She's gonna get back from work eventually. Well, you could really say fiance, but you know what I meant, right? Yeah, me today. What I'm going to do, I'm going to just study 24/7. Dude, you want to know something? I was on Twitch and there was this random girl just sitting there playing Fortnite. And I know I shouldn't say this, right? Because everyone wants to live their life differently. But she was just sitting there playing Minecraft. And dude, the things that people do, it's insane. They're just letting their brain go to waste. OMG, I need that page. Oh, this page? I got you. Are you talking about the Minecraft girl? Or you're talking about this F symbols? This is my go-to when it comes to shit. This is my sauce. This is some secret sauce that I use. It gives you different, like I use this one a lot. Do you want it? I'll link it to you. There you go. Bookmark that shit. I got a lot of other stuff too. Page of sources. Yeah, let's see. Let me see if I have anything else that I could help you out with. Or anyone else who rewatches. Let's see. Here is a... Do you know what the cheese shop is in Python? Or no? Do you know what this is? The Python package index? This is really cool. It's a big ass library of Python modules that you can download. And they're all free. So if you want to like, yeah, you could just look up all different types of releases. Like we could go to browse projects, topic, and then you can find on what type of modules you're trying to work with, like chat, post office, address book, email clients, and you can go in here and It's really cool. Ham radio, internet phone. Yeah, let's go to ham radio. Remote antenna switch. Mac, this is for Mac. Python KISS module. Here's this. KISS is a Python module that implementations the KISS protocol for communicating with KISS-enabled devices such as a serial. Yeah, it just comes with a bunch of cool stuff. I'm not gonna download this, but as you can see, you could just copy right up here, and then you go back to your terminal, and you just download it through your terminal or just any command prompts. In its sake, I'm just gonna do this. And if you want to install things without getting a permission error, after the install, you put -- user, and you're done. Downloading KISS, you see? So I'm gonna link that to you. I think that would be really, you know, sometimes if you get an error, that's because some of the versions don't work. They're outdated. But yeah, I think you should have this, buddy, if you're gonna get into, you know, really deep in this. I think you probably know what this is already. I don't know, but just in case no one knows. Yeah. Do you want to get into what I've been working on today and what I've learned today? You want to get into some neural network stuff? Want me to teach you some cool stuff? We can get into that. Yeah, actually. All right, great. I like your brain, Mr. Poflo. You're very curious, and that's good. That's how, So, let's get into it. So this is, So I'm gonna explain. First off, welcome to my stream. Hopefully you're having a great day. Poflo, why it's important for you to know this stuff, right? To know how neural network works is because let me show you something really cool. Let me spice it up. Do you know what Boston Robotics is? Do you have any recollection on what this is? Have you ever heard of Boston Dynamics? No, don't eat my brain. I love my brain. Well, do you know what Boston? Have you ever heard of this company before? So yes, I know. All right, so great. So Boston Robotics, as you know, how do their robots work? How do they work? Well, let's take a look. Wait for it. Wait for it. Wait for it. Look, see those squares? Those are called bounding boxes. It's using object detection, and object detection, as we know, uses neural networks, artificial neural networks. And it may seem complex right now. Just forget about how to do it. All you need to know right now is that the way that these robots are functioning is with artificial neural networks. And that's amazing. So what is that? So artificial means man-made. It's not created naturally, as we know. So if we look up a picture of a bottle of water, I know you know this. You have to know this, right? We all know that bottles of water, not the water inside, but the bottle of water is artificial. The plastic, the cap, this is artificial. Right, Mr. Poflo? And when we say artificial intelligence, what we're doing is making a genetic makeup, a man-made constructed architectural neural system ourselves. It's artificial. So why do we need to learn artificial intelligence and neural networks, period? Well, because you want to make robots that can detect things, detect heat. Let's actually go see. Let's see what some of these robots can do. Here's one of the robots that they have. And this robot is able to actually detect heat waves on the machines and tanks. To see if a certain part of a machine is overheating, so on. It's efficient, it's safe, it's predictable. Proactively gather data to maintain assets, right? So this guy has a controller in his hand, right? This is what the robot is seeing itself. It's seeing all of these thermal heat data, these data points, right? So it knows if something's hot or if something's too cold. But how does it know that? Because of the neural network, the artificial neural network. Now, you're probably thinking, well, how does it know if it's too hot or too cold? That's a good question. Because we know, you know about thermal vision. I mean, thermal vision, right? Do you know what thermal vision is? Thermal vision? Poflo, do you know what thermal vision is? So this is what thermal vision is. It is a type of, yeah, like the ones in the movies, right? Well, you're probably thinking, well, how does artificial intelligence know if something is hot or not? So remember what I told you yesterday, Poflo, on how object detectors work? And there's all different types of object detectors. Let's take this one, for example. Every object detector has layers. Even neural networks have these layers. There's deep, we're not gonna get to, I'm going to ahead. But you see this first image here? This one here? Let's move over here. Whatever goes inside of this layer is how the artificial intelligence will actually read and be like, okay, this is a thermal vision instance. This is an image. This is a video feed of thermal vision. And it will go through all of these layers and it'll be like, okay, and it'll determine, okay, this is hot, this is cold, this is this is that, this is this, until it gets down to the very last bit. And it's like, okay, well, I have determined the source. We have, you know, here's a dog that's really, really hot. But if we go back to this over here, back to here, it says here, let's see, gauge reading, Okay, optimal integrated thermal camera allows you to detect issue indicating hot spots in tanks, machinery, or electrical conductors. So what does this mean? This means if you learn how to make your own artificial neural network, you could buy yourself a thermal vision camera and you could go out and put it on your front porch and detect human being heat signatures, animal, bird heat mixes. You know what that means? I know I'm getting really excited about this, but that means you could literally detect every living thing that is walking outside your house. If done correctly, of course. If you do it right. If you program it right, right? And maybe on stream, I would have to go out my way to get a thermal vision camera, but maybe I might do that one stream. I might actually make we might do something like that. Now, I'm sorry if I'm talking really fast. Do you want me to go a little bit slower? Am I talking too fast, or you understand what I'm saying, right? Hopefully I didn't lose you. When I get excited about this type of stuff, I just keep going and going and going, you know? But it's cool, right? Like, some of the stuff that's going on. You there? You there? Houston, are we there? Are we there? Are we live here? Or maybe I'm just not getting messages. Let me double check. Okay, well, let's continue, just in case. Maybe he's just chilling. Now, visual inspection. I'm sorry. Employees spot to collect color visuals and perform detailed inspections with a pan, tilt, zoom camera. So obviously it has cameras, it has gauge reading, it could read with a 30 times optical zoom lens, leak detection. It can actually detect leaks of water and steam leaks around the plants to recognize equipment and degraded performance. Laser scanning. Equip Spot with a laser scanner and program routine scanning. I think you could buy one of these, but they cost a lot, I think. Are they saying you can buy this? Autonomous. And we know what autonomous means. Autonomous means something that is doing things on its own free will. It's autonomously doing everything from moving and everything like that. What is this? Teleoperation. Web-based control software allows you to remotely follow along on Spot's missions or teleoperate the all right, yeah. But long story short, artificial neural networks and artificial intelligence is one of the great staples that every programmer should know. Now, please, I beg of you, once you learn this stuff, do not become a Mr. Know-it-all. Just because you know artificial intelligence, you really truly don't. You could have an understanding for things, but let me just tell you guys this right now. We honestly do not understand. Artificial intelligence is not a complete makeup of the natural neural network. We've come close, but it's not exactly correct. So don't let it get to your head. There's always more things to learn. There's always more things to put out there. Now, yeah, let me show you guys what I've learned. Let's go ahead and close this. All right, so back to the neurons. So, what if I told you that artificial neural networks have artificial neurons? That is right. And these artificial neurons are just as similar to the ones in the human brain that can transmit data. I'm sorry. I'm stumbling over my words. Data, right? And now, if we go back over here to this image here, these layers in between, oh, actually, no. In between, let's go back to the neurons. There are a lot of neurons, right? And in between those neurons, that is called, there are coefficients, right? And those coefficients are weights. And the weights adjust in the training data phase, in the training data stage. So now we know that we have artificial neurons. We know that between neurons, there are things called corresponding weights, or better known as coefficients. And these coefficients, what are they? They're actually they're like weights that determine the importance and the strength of what to send to the next neuron, right? The importance, what's important, what's not important. Long story short, these weights are saying, okay, this is important, this is not important, and it's going to sum up those weights, and then it's going to go to an activation process, an activation function. And from that activation function, it's going to determine the false negatives, the false positives, and it's going to come out with a prediction or a candidate. It's going to give an output, and then it's going to look for a desired output. And I could be wrong in some of these things, but I've studied enough to know that that's semi what it is. Give me some time. we're going to actually go back and study to make sure I know what I'm saying. So let's go see if I know what I'm saying, first of all. And that was without looking at documentation. So let's go see. So before we go, let me say it one more time. Artificial neural networks have artificial neurons called perceptrons. These perceptrons are, there's all different types of artificial neurons. There's perceptrons and there's MLP neurons, artificial neurons. So we have singular neurons, artificial neurons, and we have multi-layer artificial neurons. And what are these neurons? What is their job? Their job is to analyze data sets. Now let me tell you something. From now on, what if I told you everything you've been doing? You've been naming your folders and everything incorrectly. So have you ever had like a project? Like here, I'm just gonna go to one. Let's go to February. You see, if we go to the Waifu detect folder, you'll see that I have a folder here in here called image sources. That's wrong. I mean, you could call it that because that's where all of your instances of your images and your PNGs images are. But there's a better name for this. What we should really be calling this is image underscore datasets. Dataset. Right? And I'll go back and fix all that and stuff. Let me go to waifu.detect, close this. Image dataset. Right. So how do artificial neural networks work when it comes to the input and the data that it's actually working with? I'm actually getting called right now. I'll be right back. I have to sit. Hold on. BRB. Okay, we are back. So I was downstairs explaining it to my mom and my family. Let's see. Okay. We're gonna turn this off. So yeah. This one guy on YouTube was making a turret with artificial intelligence. What do you think that word means? Artificial intelligence. When take away the artificial, right? Take off the artificial for just 1 second. Intelligence. When we say artificial intelligence, we're pretty much we are making a mock-up of the human mind. That's all it is, you know? And we're trying to make this, whatever we're trying to make intelligent decisions and make its own decisions and do intelligent decision making at the end of the day. So, long story short, artificial intelligence unfortunately, we got some people out here who think they know everything about artificial intelligence, you know? Like that one person who told me about what are AI tokens. That's not even fucking, like, that's not even that. Like if we go over here and we do the study, right? It might be. You know, we never know. It could be. Here we go. What did I tell you guys? In the context of neural networks, the term AI tokens is not commonly used in a widely recognized term. It is possible that you might be referring to something specific within a context or a framework. However, it's worth noting that tokens have a broader significance in the field of natural language processing, NLP. So that's what I told him. I was like, are you talking about natural language processing? And then he just ignored me because I guess he figured out that I was, you know, I knew what the fuck I was talking about. But when we talk about artificial intelligence, we are literally just talking about, we're trying to make this program do something complex, a convoluted task, and to do it proficiently and efficiently. Right? So when you say that this guy is trying to shoot at people with all he's doing, it's just object detection. He's just detecting shit, and then it makes these. It's working with the artificial neural network that are making the decisions whether to see this is a human being, whether this person is this, and it's doing that with weights. It's determining that stuff with weights and coefficients, and it's really interesting. So that guy. You should link me that YouTube channel after this stream. I would definitely be interested in going to go watch that stream. That guy must really know what the fuck he's doing if he's messing with the turrets. You know? That's insane. But let me drink some water. Okay. And close this. Where did I leave off? What was I talking about? Oh, okay. Here. So, the area between these layers, that's where the coefficients and the weights live. And these layers are responsible for taking whatever type of data set that we're working with and to process those data sets, whether it be image data sets, video data sets, audio data set. I mean, it depends, right, on the detector, on what it does. Because we talked about speech recognition, we talked about natural language processing, and natural language processing has to do a lot with, like, tokenization of a corpora or a collection of words and text. So there's that. But, yeah, so now you know what data sets are. From now on, I don't want you guys to name your folders a bunch of images or a bunch of videos. Name it video data set. Name it image data set. Or you can just name it image data. It doesn't matter. So what is a data set? A data set is, I'm sorry, I'm turning off the music on and off. A data set can be anything, right? And there's different types of data sets that you can use. You can use tabular data sets. This is in the form of like a spreadsheet. Have you ever seen like a table data set? Let me show you. Table data set. You guys will know what I'm talking about once you look at this. So here's a data set of in a tabular sense. Let me try to find a good one. Here we go. Right? So here's a data set. And data sets are widely commonly used in databases, right? And how neural networks, artificial neural networks, collect the data and process data is it gets it from data sets. And then it grabs each one of those instances, whatever is inside of that data set, and the data points, and it processes it. It uses that as its main source of input, whatever is inside that data set, right? We have app category, there's communication, there's business, there's fashion, there's entertainment, there's games. This is one row of information, and we have one which is 4. So what an artificial intelligence or a neural network would do, an artificial neural network, it would just look at this information and would be like, base its outputs on this information. Does that make sense? So it's going to say, okay, well, this is what I'm working with. This is my input data. This is the data that I'm working with. I'm going to go off of this, right? We're not going to go too deep into it, but that's, long story short, what it is. Here's another picture of a data set here. This is not important. In the grand scheme, I'm just showing you guys what a data set is. Here's an example of a table data set, right? The year, the team, the attendance, the yards, the average. This is a data set for the NFL seasons or whatever. You know, there's all different types of data sets. You can have data sets for attendance in school, maybe a data set for, you know, how many viewers join a stream, like for Twitch or for like YouTube. There's all types of things, right? I'm going to look for it in the video for the last year. Yeah, so what this guy is doing, I'm going to break this down really simple for you guys, okay? Really, in a really fun, intuitive way. Artificial neural networks are the convoluted, intricate architectures of a computational system. It determines its outputs with the data sets provided to it. These data sets and these instances, the instance as in the files or the files inside of that data set, whether that folder, whatever, that data gets sent through these convoluted layers, and it's going through these layers, and it's going through, you know, and every time it goes through one layer, it's going through these weighted coefficients, and these coefficients could be values that adjust in real time, and it's saying, okay, this is a false negative, this is a false positive, and it's just making these changes, and it goes through these layers, layer by layer, and it gets closer and closer to the answer, to what it's trying to find. And once it finds what it is, a person, a dog, a gun, a table, a crying woman, a crying man, whatever that is, whatever that, you know, a satellite, an asteroid, it's going through all these convoluted layers. And once it does that, you get your final output, the detected thing, whatever you're trying to get. That's how robots work. I don't give a fuck what anyone says who comes into my stream and tells me that's I can tell you guys, they don't want you guys to know this because they're afraid that you want to take their jobs. I don't know why it's that way, but it's as simple as that, you know? Anyone can learn this. This stuff is beautiful. It's out here for us. So do yourself a favor and, you know, don't be afraid to learn the more intricate stuff in programming. When you get into it, trust me, take my word for it. I'm not saying it's easy. I'm saying you have to read documentation in order to learn it. That's how I can speak this stuff to you guys. Do you guys see any text up here? About explaining it? No, because I studied it, right? So it's really important to note that. So what is an artificial neural network? What is artificial intelligence? Let's start with the neural network. First, let's go to the beginning of what a neural network is. Let's go to neural network, and we go to images. We go down here. So I'm trying to find an organic neural network. Here we have neural networks of like, computational neural networks. I'm trying to find one. Here, take a good look at this image here. What do you see? You see a human and you see all these wirings in her brain. No, this is a neural network, and this is actually what's inside of your brain right now. And these pathways, the strings that you see, these little lines, these little bits of string, they're called axons. AXON. The glowing parts, I guess you could really say that's the cell itself. There's a cell, like imagine a circle, and this is called a soma. And these axons actually have little terminals. Yes, you heard me correctly. Each neuron has these things called axon terminals. Let's go see. I don't want to feed you guys false information. We go look over here. Let's go see axon terminal. Let's go look it up. Neuron axon terminal. Here we go. Here's a good representation, right? So we could take a good look at this. So what is an axon terminal, right? Let's go take a look. Yeah, I'm gonna go get my food and I'll be right back, and then we can go get into this. All right, coming. I love this topic. Yeah, I do love this topic too. I'll be right back. I have to go get my food. I will be right back, and we'll get Okay, I'm sorry that I have to bounce back and forth. As you guys can tell, it's a busy day over here for me. But I'm trying to... That's the good part, because all of this is actually recording. I want to put some music in the background. Let me get my VTuber. Okay, we are back. Welcome. Let's put some music. That's why I got this thing. I'm paying $6 a month for this. Playlists. Coding. And this is a great website, by the way. I'm not going to get copyrighted. No more ads. Nothing like that. Hi, Luther. Hopefully, and anyone, not just Luther, everyone else who will come stop by my stream in the future, or even watching this on Twitch, because we're streaming on Twitch and here. You know, I say that even if we might have like one viewer, it doesn't matter, you know? Because where I was raised, even, you know, you want to spread hospitality. Anyone's welcome to my stream as long as you show me signs of, you know, hospitality as well. But let's go ahead and play this. So, neurons. You need to learn this stuff when it comes to artificial... Now, there's two types of neurons in artificial intelligence. There's a lot of types actually, but the two that we're going to talk about right now is the perceptron, right? So let's go take a look at what this is. Perceptron, here we go. Let's go do some analyzing. Open this up. Let's see if we can find it. Okay, it should be here somewhere. Where are you at, buddy? Yeah, you could really think, as my eyes are scanning right here looking for this word, this is kind of the human brain doing its own type of detection, its own type of object detection as we speak. So, what is a perceptron? Now, really pay attention here, ladies and gentlemen. What song is that? You gotta go. Sorry. Okay, great. So, what are neurons called when it comes to computational in the computer science world? They're called perceptrons. They're not really called neurons. They're called perceptrons, right? And perceptrons were first introduced by Frank Rosenblatt in 1957. Can you imagine that? Let's go look up what this guy looks like. Now, I do want to say this, guys, if you hear me talking to myself on stream, and it doesn't matter. There's something called rubber duck debugging. And you guys can do this too. A lot of really well-known software developers will talk to a rubber duck. Or you might walk into a professional Google company, and you'll see a bunch of programmers sitting there at their desk talking to themselves, explaining what they're learning. This is called rubber duck debugging. And go get yourself a rubber duck so you don't have to feel alone. Luckily, I have the company of, you know, my girlfriend and, you know, a Luther who comes in, and I got people who come in sometimes. But if you find yourself having no one to talk to about code, get yourself a rubber duck and sit there and talk to it. Explain the problems you're having. Like, look at this one. This one has actually like a console.write. I think this is console. I know that this right here is probably Java, or it's probably Angular. Right? Yeah, but we're trying out. You're doing rubber duck debugging all wrong. Okay, now this guy... Okay. Okay. So, let me eat some of my food before it gets cold. Does this all make sense? Luther, does this make sense to you? Right? Yeah, ask me some questions. What if you feel like I don't know if he's still there, but Luther, if you're there, ask me questions on what I'll tell you. I'll answer them. when it comes to neural networks and object detection, I'm 100% positive now that I will have the answer to it. And if I don't, we'll go study it. I'm eating my food right now. Hold on. I'm sorry, you guys are gonna have to hear me eat my food. You can't think of anything? Well, it doesn't matter what it is. Just come up with a random question. What do you want to know about? What's the sense of life? Well, there isn't any. Right? Let's start off there. Are our programs alive? No. What determines something to be alive? You need to let's ask what determines life? All living organisms share several key characteristics or functions: order, sensitivity in response to the environment, reproduction. Reproduction has to be one of them. Adaptation, growth, development. Okay, artificial intelligence does have development. It can respond to the environment. It can't reproduce. I think that means sexually reproduce. But if you take out that equation, could a program duplicate itself? Does that count as reproduction? Maybe. Adaptation, okay. Artificial intelligence does have adaptation and evolution. It's crazy. Homeostasis. What is this? Energy processing. What is homeostasis? Let's see what this is. The tendency towards a relatively stable equilibrium between interdependent elements, especially as maintained as psychological processes. Okay, believe it or not, yes. Okay, so this is physical, chemical, yeah, for the organism. So to answer your question, artificial intelligence is damn near close to life, but it's not alive. All right, ask me another question. Come on. Test me out on my knowledge, buddy. See what I know so I can, see if I don't want to feed you wrong information. What do you want to know about artificial intelligence when it comes to neural networks? Because that's what I've been studying so far. Artificial neural networks. Ask me even about object detection. Be like, is it possible to do this with that? Is it possible to do that? And I'll tell you if it is. I'm eating rice. Estoy comiendo arroz con tomate, cebolla cocinado, sardinas cocinado professionally, and habichuela. Con habichuela. It's good. Good stuff. See, the thing is about artificial intelligence, why the fuck would it want to even have all the stuff that humans have? Right? Because if we talk about, okay, well, it's bad that artificial intelligence do not have a physical organism form. Well, that's a plus. It won't get sick. It won't get old. It won't suffer from diseases. The only diseases that I guess it would have to suffer from is from digital diseases known as malware. But other than that, it's practically immortal. It has no weakness except for shutting it off somehow, shutting off the farm of where all these artificial intelligence are happening. Right? So, in a sense of the word, artificial intelligence is an immortal fucking entity. It's a real thing, right? It's happening. As the days and the years go by, there's artificial intelligence that has been back since like the 90s. And it's the year 2023. They haven't died. They've survived decades. So if you want to talk about immortality, my friend, artificial intelligence is immortal, right? But once you ask me a question, I'll go. You don't have to. You don't have to ask me a question. If you just want me to continue on, I'll explain more in depth about it. And then we're going to get into some studying. But I want you to know that you can ask me questions if you have any. Do not be afraid to ask questions. No? Okay. Well, I'm gonna eat some of my food right now. I'm gonna turn off my camera because I'm eating. Un momento. No, not yet. Okay. Here, I'll put this up right here so you guys can read on this if you want to, and we're gonna read this when I'm done finishing my food. I'm gonna mute myself. Okay. So, let me just say this really quickly. What do I have planned for the stream? It is officially 1:05. We made it to the it's 1 p.m. right now for me, where I live. And it is Thursday, May 18th, 2023. I'm sorry, I'm going to be doing that a lot. I kind of want to document my life of me studying this stuff, like this guy. Do you guys know who this guy is? Doc Brown? He's a scientist in a fictional movie, right? He's a scientist in Back to the Future, and he has this radio, and you'll see that a lot of scientists, they document their experiences, their hypotheses, and their experiments. They'll record it and they'll document it. So now you guys can see why I got upset when that one guy came to my stream and he said, reading documentation. Science is documentation. It's all documentation. So when he said that, he was just making me, it made me angry. It grinded my gears, So, oh look, and this is him now in the future. But yeah, you guys gotta go watch that movie, Back to the Future. Really good movie. I'm gonna turn on my web camera in a minute. I'm just eating my food right now. So, look at all these stuff here. Anime, all this stuff. Ay, no. Mi novia va a venir como a las 3, yo creo. En la comida está riquísimo. Oh, Luther, have you watched Stranger Things yet? Have you been watching it or no? I'm on season 3 of Stranger Things. Don't spoil it for me. Don't spoil it for me, though. You Only Look Once is one of the most popular model architectures and algorithms for object detection. Usually the first concept was found on a Google search for algorithms on object. Oh no. Usually the first concept found on a Google search for algorithms on object detection is the YOLO architecture. So if we look up object detection Python, object detection algorithms, it's going to be the first one that comes up. There it is. Look. You only look once. You see that? It pops up, the first one. And then we have RCNN, which stands for Relational Convolutional Neural Network. And convolutional just means intricate. Here, we'll look up the definition of what convolutional means, or convolution. What? Convolutional meaning. A form or shape that is folded in curved or tortuous windings. It's convolutional. It's intricate. What is convolution in image processing? Convolution is a general purpose filter effect for images. Here, I think we should grab that. We should grab that and put that over here. And grab that and put that over here. This information for science. So, what is convolution? Okay, so it is a filter effect for images. It works by determining the value of a central pixel by adding the weighted values. What is all this dot stuff? It is. Excuse you. So here are the most popular object detection algorithms. As you can see, YOLO comes first. Oh, hi. Hi, my loves. Where are you at? Oh, you're watching my stream from work. Wait, how are you watching the stream? On their computer? Oh, okay, hi. I need the season 3. Yeah, you need to watch the season 3. And hi, my loves. I'm just learning about neural networks right now and artificial neural networks and shit. It's really cool. You have headphones on? So you don't get in trouble at work? Oh, we're doing a web box right now. Oh, and Luther says hi. That's Poflo. Okay. I'm eating right now. Estoy comiendo arroz con sardinas. Good sardinas. It's not bad. My mom cooks them in a way where they actually taste really, really good. So estoy comiendo arroz con habichuela, con sardinas, and they're spicy sardinas. You know, some people don't like them. I don't like sardines either, but the way she does it, it tastes good. Let's just put it this way. I'm getting closer and closer to making my first neural network. What does that mean? I'm going to be able to detect heat waves of all the animals in my fucking backyard. And my artificial intelligence is going, my AI is going to do it all for me. But I got to still study. There's some stuff that I still got to learn. But we're getting closer to the end goal. Yeah, I like, where does this end, right? Because if you think about it, what if I told you I'm here surviving on Beltiva cookies? Oh my god, you had to write the brand name? Don't get me banned. That's good, my loves. Yeah. And I talked to my mom, because my mom's a nurse. You guys don't know this yet, but my mom is a nurse. Well, my girlfriend knows this. My fiance knows this. But Luther, you don't know this. My mom's actually a nurse. She used to be. She's retired now. But she told me that neurons in the brain, they really compile information. They're like little tiny, they transmit data back and forth with electrical charges. And they're like their own little tiny, we have millions. If we did not have neurons, what if I told you they're part of our neurological system, right? So if we didn't have them, you would just fall to the ground. You would just fall to the ground. You wouldn't even know what the hell to do. It's insane. Oh, hi. I accidentally pulled that up. Sorry. My bad. Oh, here's the NASA Webb Telescope. But my loves, I hope you have a great day at you know, work and everything. And did you know that the NASA Webb Telescope has over 2.9 million followers now? I'm one of the followers though. And this is what it captured. Did you guys know this? That the NASA Webb Telescope actually captured frost, water vapor, coming from an asteroid. No, an asteroid. A comet. And this water vapor suggests that maybe it is possible that the source of water on Earth is from another galaxy. Like, they're saying that, you know, breakthrough origins of the water of Earth. They're saying that the origin of water on Earth is from fucking comets. That is a breakthrough that they made. I mean, here's the imagery right here. Here's the comet illuminating water. Water. Bro, that's insane, right? Yeah, exactly. I thought it was like a fucking portal or something looking at this. I was like, what is that? Our water wet? Did it really? I didn't know that. Okay. I'm sorry, I'm eating my food right now. That's why I'm not talking. Ask ChatGPT everything. Okay, so they're saying the origin of water on Earth is believed to be closely tied to the planet's formation and early history. So the formation of Earth, water just happened to be there? Ah, dude, I don't know. Is that possible? Are you telling me that water just was just produced? It could be possible, though. And if this is a true fact, how many other planets do you think have water on it? Not in our galaxy, though, because we've checked so far. Like, whole planets with bodies of water. That's what I mean. All of our rocky planets have water? Do all... have water? It's not uniformly present on all rocky planets in our solar system. The presence and absence of water depends on various factors, including the planet's distance from the sun. Right? Because the closer you are to the sun, I mean, the less water you're gonna have, correct? So, and the Earth and the sun is just a huge, gigantic gas ball of fucking destruction. Really, it's formed of. And the sun is really complex, too. Yeah, because Mars is closer to the sun, right? What's the... We're closer to the sun? That makes no... Okay, that's kind of gross right there. That, I don't know. I can't eat that. There was like a weird string of whatever came off of it. I don't know. This is making me not want to eat it. Huh. Well, how's your day so far? How's your day been? You come back home very soon. When you come back home, we'll go watch some Stranger Things. And then, yeah. Okay, I think I'm done eating. Can turn on this. It's been okay. Yeah, my day has been alright. I've just been studying. You know how I do. Just studying. Study. I saw this girl playing Minecraft. She was just sitting there, and I just thought to myself, how... I know this is gonna sound very prejudiced, but how she was just wasting her life away. How people just waste their life away just playing video games all day. It's their life, right? But I wish I can take back all the times... What do you mean, test? What do you mean, you're at work? What are you talking about? Oh, the evaluation test for what they wanted for the promotion? I remember now, fuck. So, wait. Didn't you study last night for that? So why did you fail? And you shouldn't be saying stuff like that on stream. It's no one's business, really, if you did or not. But it's out there now. Because these streams are recording. You just put it on for history forever that you flunked the test on YouTube. I can't remove it either. Be careful what you say. I'll tell you when I'm home. Yeah, tell me when you're home, my loves. You can still talk, but just don't spill sensitive information like that. It's the fucking internet. You know, some people are just assholes. So maybe someone will make fun of you for that. Or look down at you. I mean, I don't care. I mean, people see me like fail on stream all the time and learn new things, but you're not a streamer, so they'll be like, oh, well, yeah, you know what I mean? Because they know I'm intentionally trying to, they know I don't give a fuck, that I'm just studying and doing my thing, you know? But they'll be like, oh, well, she might care that we make fun of her for flunking a test or whatever, you know? It doesn't make you dumb either. It just means that you have to keep studying. Oh, you're retaking it? That's good. Yeah, Luther asked me a long time ago, what is this? This is actually a this is stocks and bonds. And this allows you to actually see the fluctuations and the inflections in the stock market for a specific stock. So I'm not really deep into this, but I do own 2 stocks. Me and my fiance own 2 stocks here. Yeah, and I don't look at it all the time, but it's doing well, because if you look over here, it's 11.55. This one's 7.97. It's up. It's going up. It's showing signs of health. It's a healthy, good. I could be a bad boy, give you money now. What? That was the most random thing ever. Oh, I could be give you money. You talking about, oh, I'm so confused. Luther, do you mean and give me money now? What do you mean? Like, give me money. What do you mean by that? Save your money. Do not donate. I don't even think there's a way to donate, I think, on YouTube. I don't know what's happening. No, I think Luther was proposing to donate money to stream, maybe. That's the only thing that I think. But you don't have to give me money. It's fine. As long as we all learn something new, that's what matters to me at the end of the day. Nothing, never mind. No, it's fine, it's fine. Twitch? Oh yeah, I do have it, so you could. Yes, my loves, yes. My break is over. Okay, sounds good. I'm gonna go back to studying, and you go back to being the amazing woman that you are. Okay? I love you. When you get back home, we'll watch Stranger Things. I don't know. I'm gonna tweet this. Google Chrome. Whoa, I've received 100 messages today with Restream chat. There we go. Guys, look. Thank you. Whoa, I received 100 messages today with Restream message.chat. And it's just us two. It's just me, Mrs. Genesis, and Luther. Engage in multi-chat. We would probably have more people talking if I enabled chat on Twitch, but the people on Twitch are mean to me. I love you too, my loves. I love you too. Luther, that's cute. Yeah, it is. I know it is. Yeah, but we would have more people talking, but the people on Twitch sometimes, they can be assholes, dudes. I'm not even gonna lie. That's why I switched over to YouTube. Because I talked about this with my girlfriend. The science and technology, the software development categories are like high school. Everyone in there knows each other. It's just... That's the only reason why I just don't stream exclusively to Twitch anymore. And I stream to Twitch just to see if we can find someone nice. Because Poflo's nice. Right? Because we found Poflo on Twitch. So there might be someone else who would come from there, you know? So we're still giving them their little chance. We're giving them their little chance. Okay, break time's over. No more food. Time to work. Time to study. Okay, we can... Oh yeah, Axon terminals. We're gonna talk about Axon terminals. Yeah, you're really chill. Dude, you're really chill. I'm not even gonna lie. You're probably one of my favorite viewers. Other than my girlfriend. My girlfriend comes first, right? But then you come second. You're my second favorite viewer. We can't put my girlfriend on second. But you're a very chill viewer, man. And supporter. So, let's turn off music. It is time, ladies and gentlemen. Get comfy. We're going to continue, and we're going to get into the topic of Axon terminals. Now, this is fucking insane. This is about biology. We're talking in a sense of biology. Like, why? You know, a programmer sitting there, you're probably sitting there scratching your head. Why? Why do we have to learn this shit? This shit's not... And to that person saying that, trust me, guys. I'm grabbing your shoulders right now. Ignore those type of people. I'm telling you, you have to know this stuff. You know, it helps. It helps to know this, right? Because what we're doing is reverse engineering. And what did you think the initial computer scientists had to do to make a artificial neural network? They had to reference what? They had to reference actual neural systems, neural network systems. So that's exactly what we're doing right now. Yeah, and I'm not going to lie to you guys. There might be 50 more streams on this. This is not done in a day. I like to take my time when I learn things. I like to really, truly understand. So if someone comes to stream and they're like, oh, well, you don't know this. We could be like, yeah, we do. We got 50 other streams behind us proving that we know what we know, you know? So without further ado, neurons. Let's go into this. Drink my soda. Okay. Sorry, I had to drink my soda. So, what is an axon terminal? I'm going to read this out loud. This is the documentation I'm going to read now. An axon terminal is any of the button-like endings of axons through which axons make synaptic contacts with other nerve cells or with effector cells. So what does that mean? I wish they would bring up a bigger picture. Is there any pictures? Okay, so here's a picture. So an axon terminal is the end points of, you know, of this neuron. Look. So here's the axon, right? The axon is the cable. Here, let's bring this out so you guys can see. And this does matter because this is kind of how like what did I tell you guys? The cell body, which is called the soma. We have the axon, which is like this cable-like structure. You see this yellow stuff? Imagine that's the data being sent to the axon terminals, right? We're not going to get into the nodes. We're not going to get into this. We're not going to get into that. I just want you guys to focus on the nucleus, the soma, and the dendrite, and the axon terminal. You see this end point here? The very, very end right here? That's the axon terminal. And then we have the axon itself, which is this cable right here. And then we have the body of the cell, which is the soma. Okay? That's all this. We're so zoomed in. So let's go see what this is. At the axon terminal, synaptic vesicles containing neurotransmitters are docked. Wow. So these are the neurological transmitters. So at the end, these are responsible for the transmitting of the electrical charges of the data, right? So the axon's almost like it's like a tunnel for the data to travel through. And we have the nucleus. I don't know. I guess the nucleus creates the data. Let's not get too deep into it. We have the tunnel, we have the home, we have the tunnel, and we have the departure right here. At the axon terminal, synaptic vesicles containing neurotransmitters are docked. Upon activation, oh my God, guys. Now, if you guys don't know why I'm clapping, I just had a revelation. In the sense of artificial neural networks, there's these things, there's a process that's called an activation function. An activation function. After all of the weights and the coefficients have been processed, it sends it to an action function. So the action function is possibly being named, and it's being named after the actual activation method in actual neurons in the biological brain. So they probably renamed the activation function after the activation method in actual neuroscience. That's cool. Did you know that? But that's just a wild guess, right? How many times, guys, have I actually had like revelations on stream and I was right? So far, I have been right so far, right? I'm on a winning streak right now, but you know, it's just common sense, right? Anyone could figure that out. Activation function. You just put two and two together. So we're in blah, blah. Upon activation by a graded potential, I don't know what that is yet. I haven't studied that. Or by an action potential. Okay, an action potential, I'm thinking, is the act of actually transmitting that data. So action potential is actually the action of shooting those electrical chemical charges of electrons, yeah, of the presynaptic neuron. The cell allows the entry of calcium ions. No, you see how they took calcium ions? They're just putting ions. This triggers a cascade reaction resulting in a synaptic vesicles fusing the membrane of the axon terminal. The synaptic vesicle proteins that are activated by the calcium ions form fusion spores through the neurotransmitters can exit. The neurotransmitters exert their effects on the target cell within the limited span of time. Okay, so right now we're talking about this neuron right now. The axon terminal is focusing, it's targeting the next neuron to actually send information to. So right now it's honing in with its, you know, it's on the target cell. The target cell is going to be the next neuron that is going to receive this information, this data, right? Now remember, this is all in a sense of how, you know, everything works. Soon after, the neurotransmitters are aborted back to the presynaptic neuron or degraded metabolically, by enzymes. The axon terminal is therefore essential in cell-to-cell communication. So now we know how neurons actually work in the brain. They work by a cell-to-cell communication system. And what is actually in charge of sending that data and that communication with one another? Well, the neuron themselves. But which part of the neuron actually transmit that data is the axon terminal. That is actually the gun, the smoking gun, right? It is crucial in providing a means of neurotransmitters to the exit of a neuron and relay signals to the target cell. Now, what does that have to do in a sense of when it comes to programming, right? Because we as human beings have artificially created this system. The system that I'm talking about has been created artificially. In come the word artificial intelligence, because artificial intelligence is just the genetic mock-up of neuroscience. So, and then here we have an image. I think we have an image here. Here. So you see all those tunnels? So think of it like this. The really bright lights that you see here could be the cell. Could be the cell, the soma. And all these little, let's zoom in. All these little wires, these are the axon. These axon are going to meet their relative ends, and they're going to meet a axon terminal. This axon terminal is going to focus on a target cell, the target cell that is closest, or whatever cell it's going to target, and it's going to shoot that communication to whatever type of data, whatever it is sending to that target cell. That target cell will then receive this data, and the process repeats over and over and over and over until we finally get an output. So right now, I'm going to look up a picture, and you tell me what you think this is. Bird, right? Boom. That's how fast our brain works. That's how fast those neurons are working in your brain, right? Now, if you don't know what the fuck this is, go see a doctor. It is super. Is it? I be back later. Fuck, I need to clean the house. Okay, go ahead and clean the house, Mr. Luther. Mr. Luther is badass. Mr. Luther's a badass, dude. Okay. Catch you later. So, yeah, we look at the picture of a bird. What the fuck is this? It's a bird, right? Your brain is so complex. The neurological system, the neural network in your brain, the neurons are that fast. They're just incredibly fast, you know? Now, there's some people who were born without, you know, the ability to do that, you know, unfortunately, but I'm explaining what this stuff does. Now, let's ask the big question. What is the point? What is the point and the final job of a biological neuron? Okay, we're gonna have to, yeah, I messed up big time. Because that's the question, right? Let's see if you guys can get this. I want you guys to not look it up on Google. I want you to just go off what you think is going to be the answer. And I want you guys to sit there. What do you think the point is? Let's see. See if we can figure it out. What is the point and task of a biological neuron? Here's going to be GenesisGir's assumption. This is my hypothesis. Well, we have studied that these neural networks take data sets and it takes information, and it does an analysis of this information, and it passes this information through this network of other neurons. And it does this continuously until it has a desired output. So my final answer is I think that the purpose of neurons is to analyze data and to transmit data and to receive a final output on this data that it has gotten from the data set, from the inputs that it receives. To handle data. Let's see. Song's killing me right now. What the fuck? Why do I have this on here? Get that shit out of there. Why do I have that? All right, here we go. Okay, so here's the answer. You ready? The final point and task of a biological neuron in the human brain is to transmit and process information in the form of electrical and chemical signals. Bingo. We got it right on the nail. I was right. And if you guys got it right too, give yourself a pat on the back. Neurons are information transmitters. That is what they do. They transmit information. And that is their long-term goal. That is what they do. And these axons, this information travels through these axons and make their way to the axon terminal. The axon terminal finds another target, and it's even there's more convolution going on there. I know there's probably more stuff going on than just that. So please excuse me if you do this professionally. I've been doing this for 4 months. I'm currently learning, and I just love learning. Okay. So maybe you could come into stream if you want to, come into stream and explain it to me in a nice, positive way. That'd be great. But if you come in and tell me in a negative way and tell me that I don't know what I'm saying, well, of course, if I don't know something, it's because I haven't learned it yet. And, I've even stated in my streams, I take everything that I say with a grain of salt. I am not a professional. And everything that you're practically watching a human being learn in real time. So some of the things I may say may be incorrect. Some of them may be right. So with that information, let's continue. So biological neurons are the fundamental building blocks of the nervous system. They receive input signals from other neurons through specialized structures called dendrites. These input okay, so they receive the signal through the dendrites. So the dendrites receive the electrical signals from the axon terminals. I'm thinking these input signals can be excitatory, promoting the generation of electrical impulses, and inhibitory, reducing the likelihood of electrical impulses. The neuron interrogates these signals at its cell body or soma. So the neuron integrates these input signals at its cell body in soma. If the combined input signals reach a certain threshold, the neuron generates an electrical pulse known as action potential. This action potential propagates, it births, it breeds down the neuron's axon, a long projection extending from the cell body. We know that, like the tunnel, right? The axon carries the electrical signal, and at the end of the axon, it branches into many smaller structures called axon terminals or synaptic terminals. These terminals form connections called synapses and other neurons. When the action potential reaches the axon terminals, it triggers the release of chemical messengers called neuron transmitters into the synapse. The neurotransmitters diffuse across the synapse and bind to receptors on the dendrites or cell bodies of the next neurons in the neural circuit. This transfer of signal from one neuron to another occurs through synaptic connections. The task of a biological neuron is to process and transmit information through its complex networking connections. Neurons receive input signals, integrate them, generate output signals that are passed to other neurons. This communication and coordination of signals allow the brain to perform various functions, including sensory perception, motor control, memory formation, and cognition. Okay. The overall function of a biological neuron is to contribute to the complex computations and information processing that occur in the brain, enabling the brain to interpret and respond to stimuli from the environment and regulate bodily functions. And that, ladies and gentlemen, is what that is. So this does play a huge factor in programming. Huge factor. So let's go back over here to the Axon terminal, and then we have all this. Let's see if there's anything else. We can actually close this. We're not actually going to be writing any code today. Just going to be studying right now. Cytosis. Okay, so I'm going to go take a nap. Been studying for 3 hours so far, 3 hours and 35 minutes. This is going to be the stream for today. When I come